Motion. In this video, we try to study about motion. The motion is the most fundamental aspect of physics. In this universe, an object can either be in a state of rest or state of motion. To specify motion, we need a reference. What do I mean by that? Let me give you an example. Assume there is a boy running in a ground. If a boy is running in a ground, he is running with respect to the ground. So this ground becomes a reference based on which we specify the motion. So reference is compulsory for specifying motion. Let's try to describe what a motion is. Motion is a change in position of a body. So what do I mean by that? Let's say that there is a body which has moved from position A to position B. Here position A becomes the initial position and position B becomes the final position. So he has changed his position gradually from A to B. So we say that he has moved from A to B. Now, so there are many ways in which he can move from initial position A to position B. It can be along any path, but the simplest of the path is a straight line. So let's look at a problem involving moving through a straight line. Here we have a body which has moved from A to C and it has moved through B. Now AB is given us 15 kilometers and BC is given us 20 kilometers. So I have to find what is the total path length that is covered by this body. So we call it as distance. The total distance moved by the body, what is it? So it can be obtained by simply adding the individual distances, the individual paths from A to B and B to C. So we have AB plus BC equals 15 plus 20 and we get 35. So what can we conclude from this? So we can conclude that the total distance obtained is obtained by adding smaller distance. Okay, so we have to find the total distance AC. So we take the smaller distances covered and we simply add them. And finally, we make a statement: the distance is just a positive number, a magnitude. We didn't take minus 15 or minus 20. We have just taken 15 and 20, which are just the positive values. Therefore, the distance for measuring distance, we always take the positive value. Hence, we call it as just a positive valued quantity or magnitude. Now let's consider a situation. Here we have got a body that has moved from A to B and then B to C and C to D. So the initial position is at A and the final position is at D. So the A, B, B, C and C, D are given in kilometers. Now let's ask the question, what is the total distance the body has moved? So the initial position is A, final position is B. So he has taken this path. So the total distance will be the sum of individual smaller distances. So we'll have AB plus BC plus CD. So that will be 10 plus 20 plus 15 kilometers. So finally we will get 45 kilometers. Now let me ask one more question. So this is a long path connecting initial and final position. Can I have a short path? So what is the shortest path between initial and final position? That is A and D. So if I look, I have marked it by a dot. So from A to B. So it is directed from the initial to the final position. So this corresponds to the shortest path, and this shortest path is given a special name and it is called displacement. The shortest straight line path connecting the initial and final position of a body is called displacement. So we have distance and now we also have displacement. So let's see how they are different. So I am going to draw it again. So this highlighted path, it corresponds to distance, and the dotted line corresponds to the shortest path and we call it as displacement. So from this we can see that the distance is longer than displacement. In general, so we can have always this condition is satisfied. The displacement is always lesser than or equal to distance. It cannot be larger than the distance. And displacement, so one property is that we know that the distance is always positive, but displacement can be positive as well as negative. It depends on the initial and final position. The distance is always positive. Hence we take just the magnitude of it. Now, the distance and displacement are measured. What are the units in which distance and displacement are measured? Distance and displacement are always measured in common units like meter, kilometer, centimeter.